Hello, good day to you. Welcome to the lesson on 11.4 polygons. I'm now on page 29 of your notes and let's begin. Well, a closed plane figure with three or more sides are known as, that's right, a polygon. And if you have a regular polygon, that means this polygon has equal sides. Please write down the notes with me. And all the angles are equal angles. Now let us quickly write down the names of the polygons we have here. We have learned that this is a triangle in primary school. Four-sided figure are called quadrilateral. And okay, as you can see, the words will fly. I'm going to write the word outside. Okay, Pentagon is the next one. Five-sided figure. We have a famous building in the US called the Pentagon. And then we have the six-sided, start with H. Yes, the Hexagon. Seven-sided also start with H, but it's known as the Pentagon. Sorry, it is the heptagon. Not Pentagon, I said it wrongly. Heptagon is the correct word. Eight-sided, of course, like an octopus, which has 8 limbs. And octagon has 8 sides. Now I'd like you to squeeze in one more. Nine-sided is called the nonagon. N, just like the number 9. And then number 10, just like a decade, this is a decagon. And then 11, you can go find out on your own. The last one is 12-sided, which you won't see very often, but it's good to know, is the dodecagon. Right. Moving on to the next page. Now let's look at line of symmetries. Lines of symmetry. Lines of symmetry. Let us look at all 6 lines of symmetry. So we have one printed for us. Get ready your ruler and draw the other one here, cutting the angle, and one more over here, cutting the other pair of angles. Now, are there any more? Yes, because we can still cut this into 2, such that half is the mirror image of the other half. Please draw nicely. I'm sure you can draw nicer than me. And this way, then we have a total of 6 lines of symmetry. Moving on, this rectangle, do you think there is only one line of symmetry, or are there more? Okay, so we can have this horizontal line of symmetry and this way down. Okay, what about the trapezium? Yes, you can have the line of symmetry vertically. What about horizontally? Will there be any line of symmetry this way? So now let's check it out. If this is the mirror, this point must be reflected here. But there isn't any over here. So we can't have this line of symmetry. So there is only one line of symmetry. Whereas rectangle we have 2. What about this isosceles triangle? We can have 1. And that's about it. Because if we are going to cut this way, there's no way I can divide this equally into 2. So no, we only have 1. So now let's look at this parallelogram. How many lines of symmetry are there? Now let's explore. If I'm going to cut this way, horizontally, will this point be reflected here? None over here. There is no image over here. So I'm sorry, this way we can't. What about this way? If I cut this such that the angles are being divided, well, as you can see, my line has disappeared. What happened? If I have this image, it should be reflected somewhere here. Somewhere, if you fold this paper, It should be reflected somewhere here. But there is none over there. So a parallelogram, in this case, this one, has no line of symmetry. Okay? Yes. For this parallelogram. But it is not true for all parallelograms. Now what about rotational symmetry? Well, it's not in the syllabus, but it's good to know. There is, if I were to rotate this equilateral triangle, how many ways can I rotate it such that I get back the same image? Well, this circle is just to indicate that this is the first point, and then it is actually not consisting, it is not part of this triangle. So just imagine this triangle without the circle, but this is an indication of the first point that we are looking at. So this is the first image, second image, third image, and we can get three images by rotating it 3 times. So the order of the rotational symmetry is 3. What about the star? What is the order of the rotational symmetry of a star? 5 points. So we can rotate it 5 times. Rotational symmetry is 5. Hexagon. What about the hexagon? What do you think? If you have chosen 6, you are right. And then this one, the arrow is 2. Now let's move on to the next page. We are at interior and exterior angles of a polygon. This part I must go slowly and explain it well. First, what is an interior angle? Well, as the name suggests, the interior angle is inside the polygon. So, for example, this is a pentagon. It will have a total of 5 interior angles. Now let's take a look. We have 1, 2, 3, 4, 5. Now when I extend this line in a certain direction, not both ways, but if I were to extend it this way up, this way, and then this way, all the lines in one direction, one side only, not both sides, we are going to form the exterior angle next to the interior angle. And how many exterior angles will there be? There will be 1, 2, 3, 4, 5, back to this line. Now if we are going to look at the exterior angle again, can you see that when I draw this line from here to here and continue on, what will be the sum of the exterior angles formed? Let me use it by using another color. 1, stop here, continue, and 3, 4, 5. Can you see that I'm actually forming a circle outside? And if I were to sum all the interior angles up, I should get 360 degrees. Sum of exterior angles of this pentagon is 360 degrees. Interesting. And what is another interesting thing about the sum of a pair of interior and exterior angle? What is the sum of a pair of interior and exterior angle? What is the sum of a pair of interior and exterior angle? Yes, they all lie on the same line. Adjacent angles on the same line adds up to 180 degrees. So I am going to use this triangle that we have to draw to explain the understanding again. First, we are going to draw a triangle. Triangle, any shape. Sorry, any length, not shape. This is a triangle. Now Mrs. Liao is going to extend. I'm going to extend the sides in one manner. One way, this way. And then only one side. And then this side. And then over here. So now we need to indicate the interior angle. So we are going to first indicate the interior angles. So here we have interior, interior angle, interior angle, interior angle. Let's try squeeze in. Interior angles are inside. What about the exterior angles? From here to here, exterior angles. Here to here, exterior angle. Here to here, exterior angle. So those that are in red are exterior angle. Now can I ask you, will the exterior angles of a triangle add up to 360 degrees? I add this and this and this. That's right. I add the exterior angle, and the sum of exterior angle is 360 degrees. And if I take one interior angle plus one exterior angle, I must get 180 degrees because they lie on a straight line.